Hi, my name is Victor and this is a demo of my application for the OpenCV AI Competition 2022. The problem that I have is that the floor in my flat is not totally horizontal near the walls and I want to place a bookshelf there. Previously I installed adjustable legs on another cabinet, however on a particular bookshelf it wouldn't be that easy because it stands on the side panels. So my solution is to build a 3D scanner to scan the floor and then 3D print perfectly fitting parts to level the bookshelf. I have attached a laser module to a pen-tilt device I built from Lego, which I can control from my application. The idea is that my software will sweep the area with the laser and calculate the 3D position of the laser dot by triangulation. And I'm using two PlayStation 3i cameras to track the laser. Before I can scan the floor, I need to calibrate the cameras. The first step is intrinsic calibration. I place the cameras on a desk for easier access. The aim of this calibration is to find out the internal camera parameters like the focal length and distortion. I'm using the built-in OpenCV method, where a checkerboard pattern is shown from different views, and after I have enough samples, the intrinsic parameters can be calculated. The result of the calibration can be checked by switching to an undistorted camera view. The next step is extrinsic calibration to get the position and orientation of the cameras. Here I am selecting at least 4 points on the camera image and I am entering their 3D coordinates to create a mapping between the pixel coordinates and 3D coordinates. I have placed some color tapes on the floor on a half meter square to make it easier. After clicking calibrate, I can verify the calibration by switching to the 3D view. I also need to turn on the laser and adjust the exposure time to actually start tracking it. Now I can track the laser position in 3D, but since this last step wasn't that precise, I'm doing bundle adjustment to further refine the camera parameters. However, the extrinsic calibration step is still needed because it gives a good starting point for further optimization. I'm going to scan an area on the floor to capture data for bundle adjustment. First, I need to select the 4 corners of the area to scan. To do this, I'm moving the laser to the corners and storing their pan and tilt values. During scanning, this area will be scanned uniformly defined by these 4 points. Now that it's set, I can start the process. Now that I have these points, I can start the bundle adjustment. It minimizes the triangulation error, or to be precise, the reprojection error of these points by slightly adjusting the position and orientation of the cameras, and as you can see, it improved the error. So now I'm able to scan accurately, however the horizontal plane is slightly off compared to the real one. Remember that during extrinsic calibration I assume that all 4 points lie on the same plane. I have 3D printed this leveler, which has adjustable legs that I can change until the bubble levelers show that it is horizontal. The other cool thing is that there are LEDs that could be controlled by my application over Wi-Fi. I'm using an ESP8266 microcontroller based board for this. I have placed the leveler on the floor and adjusted the legs to make it horizontal. Now, in the application I can hit leveling, which turns on each LED and captures their 3D position. And from this, the cameras are adjusted to match the real horizontal plane. That was a lot of work, but finally I can start scanning. The process is the same that we saw in bundle adjustment. I need to select the 4 corners of the area that I want to scan, set the scanning resolution and start it. After the scanning is done, I can export it to a wavefront object file, which I could import, for example, to Fusion 360. I'm cleaning it up before 3D printing it because the area that I scanned is a bit larger than what I need, so I need to cut these parts off. Now that it's done, let's start 3D printing. So, here is the piece out from the 3D printer. It looks pretty good. And now the moment of truth. I think it looks pretty good, better than I expected. It's not a perfect fit, so for the real bookshelf, I'm thinking about placing a thin layer of rubber under it to compensate for the small imperfections. Alright, out of curiosity I tried scanning some other objects. First a pillow, which looks pretty good. Then I scanned a part of a vase. It was a bit tedious because I had to make sure that the laser is always visible from both cameras, that's why it's just a small portion of it. It would be cool to scan objects with higher resolution, but it is limited by the current LEGO-based Pentil device and its control, because as of now it is hard to adjust the rotation precisely by small amounts. But that's for another time. So that was my demo of my 3D laser scanner, thank you for watching it.